What is the difference between good and bad learning? One aspect to enhance learning is to include gestures in your teaching. Pupils who watch a teacher who gestures and point tend to gain a better understanding and an improved memory. Although these pupils and students show an improved learning, they cannot match students who also imitate the gestures themselves. Gesturing can thus play a causal role in learning, perhaps by giving learners an alternative, embodied way of representing new ideas. Children's learning can thus improve just by encouraging them to move their hands. The same phenomenon is found in remembering visuospatial items. A possible mechanism behind this is a multimodal encoding in an embodied representational format, a representation that is less demanding on working memory and facilitates a stronger long-term memory. Gestures may also increase learning by linking the external environment with inner mental models. Another alternative possibility is that gestures merely help to focus the attention to vital properties of the problem or task.
Maybe we should start to examine if we can reproduce the previous result with a PC.
Yes, and compare it with a group of iPad users interacting with their hands instead of a mouse.
20 subjects were selected randomly among students who performed a task, consisted of a spatial visual assignment in a grid system. After the task, the students played a game of Minesweeper for 2 minutes. So how much did the students in the iPad group remember of the first pattern, compared to the PC group? The results showed a slight higher correct answer rate in the PC group. We could see a tendency of a motoric memory in the iPad group compared to a more visual memory in the PC group, something that can explain the iPad user's tendency to score 0 in the post-test. There was a tendency of shrinking mental images in both groups, resulting in a denser pattern. Maybe the task was preventing the participants in the iPad group to develop a visual view of the pattern, which in this case may have been less efficient in contrast to a more exact coordinate system. There are examples when gestures can be negative for learning. For example, adults who are gesturing during solving a gear problem actually perform worse than adults who are prevented to express any gestures. The explanation is that gestures handle a rule-based strategy, much more efficient than modeling the movement of each gear with hand gestures. The conclusion found in the current study is a tendency of different memory encoding of participant using a touch screen compared to traditional mouse interaction.